Let's say you all of a sudden were plopped into the middle of nowhere with absolutely no phone, no watch, and just the clothing on your back. You are also told that you'll be rescued in 365 days, exactly at noon, and you better be exactly on time too. In such a scenario, what would you use to approximate the passage of time? The sun, but of course the sun. One of the fundamental units of time, one day, is related to the motion of the sun. It's called a solar day, the interval between two successive appearances of the sun on the meridian. Using the system of latitude and longitude on Earth, the meridian is like a line of longitude. In more simple terms, the solar day is a measure of the period of Earth's rotation relative to the sun. Consequently, a solar day will be seen by you as the time that passes between high noon today and high noon tomorrow. A solar day has an average length of 24 hours. This lesson will explain what this has to do with mean solar time, apparent solar time, and the more famous standard time. What you may not notice by simply staring at the sky in desperation, counting time as you wait to get rescued, is that the length of the solar day changes during the year. That's because the sun moves along the ecliptic at a varying rate throughout the year. The ecliptic is the apparent path of the sun against the background of stars. The change in the solar day is subtle. There's only about a 1-minute difference between the longest and shortest solar day of the year. As you ponder this, you decide to look around for any supplies you can find to help you keep time. You get extremely lucky. You find a plain old working wristwatch. Such a watch keeps mean solar time, the time kept with respect to the average length of a solar day, or 24 hours. As you keep searching for more stuff, you find a sundial. All of a sudden, after being forced to stare at the sun's path along the sky to keep time, you are flush with timekeeping options, but they're not all the same. A sundial keeps time according to apparent solar time, the time that's kept with reference to the sun's actual position in the sky. If you were to stand there long enough, looking at your wristwatch and the sundial, you'd notice that their times would not be synchronized over the year. The difference between apparent and mean solar time can be over 15 minutes. The discrepancy between mean solar time and apparent solar time is known as the equation of time. This can really complicate your rescue's exact timing. Which option do you go with then? Let's think about this. The sun crosses the meridian at noon. The exact moment the sun crosses the meridian depends on a person's longitude. That's essentially saying that unless your rescuers are exactly north or south of you, their quote noon will not occur at the same time as your quote noon. That could totally mess up any rescue attempt. In order to overcome this problem, time zones were created. A time zone is an area of Earth about 15 degrees wide in longitude that has a uniform standard time. Standard time is the official time kept in a time zone, typically based on the mean solar time of the central meridian in each time zone. Since a time zone varies in longitude, based on what I said before, you should understand that even though your watch may read noon, it may not truly be the time the sun crosses the meridian you're on. But such sacrifices in accuracy of time have been made by people because the difference of actual noon versus that read by your watch is usually less than 30 minutes. Even 30 minutes is not a huge difference in apparent solar time, and so it's far more convenient to standardize time than worry about constantly having to adjust it with every little step east or west of your position. Overall, if your rescuers are in your time zone and using a watch, you can easily synchronize your rescue without having to adjust your watches or having to worry that your sundials are reading noon at different times based on small changes in longitude. A solar day is the interval between two successive appearances of the sun on the meridian. The length of the solar day varies slightly during the year because the sun moves along the ecliptic at a varying rate. The ecliptic is the apparent path of the sun against the background of stars. Consequently, people keep time using a fictitious sun, one that has a noon exactly 24 hours apart, regardless of whether the real sun is on the meridian at 12 or not. Thus, we run our civilization on mean solar time, the time kept with respect to the average length of a solar day, or 24 hours. This kind of time doesn't take into account the sun's true solar day length variations. Instead, we just use an average number throughout the year. This is different from how a sundial works, which is based on apparent solar time, the time that's kept with reference to the sun's actual position in the sky. The discrepancy between mean solar time and apparent solar time that ultimately arises is known as the equation of time. To make our ability to tell and synchronize time easier, time zones and standard time have been introduced. A time zone is an area of Earth about 15 degrees wide in longitude that has a uniform standard time. Standard time is the official time kept in a time zone, typically based on the mean solar time of the central meridian in each time zone.